Hey everybody, and welcome back to another physics lesson. In this video, we are going to move on to the conservation of energy. We've been talking about energy quite a bit recently, so let's start to organize all this stuff. We can start with the broad category of energy, and this breaks down to two types: mechanical energy and non-mechanical energy. Mechanical energy is the energy we've been talking about recently as it pertains to kinetic energy and potential energy. Just a refresher, kinetic energy is energy an object has when it is in motion. Potential energy is based off the position, shape, or condition of an object, and the types of potential energy we talked about were gravitational and elastic potential energy. Gravitational potential energy is the energy an object has when it is in a gravitational field, and it increases or decreases based on how high the object is. Elastic potential energy has to do with objects that stretch or compress, such as springs or bungee cords. Let's define mechanical energy. Mechanical energy is a sum of kinetic energy and all forms of potential energy. Simply put, the kinetic energy plus the potential energy equals the mechanical energy. Non-mechanical energy is associated with energy of particles or objects that are too small to be seen. This could be nuclear, chemical, internal, or electrical. For this video on conservation of energy, we'll be only talking about mechanical energy though. So, what does the conservation of energy say? It states that the total energy remains the same, nothing is lost, and energy itself can change form. For example, if a person jumps off an elevated height, they lose potential energy as the height decreases. However, in return, as a person falls, the kinetic energy increases because the person gains speed as they continue to fall. The total energy throughout the fall will remain the same. The equation for conservation of energy is the initial potential energy plus the initial kinetic energy equals to the final potential energy plus the final kinetic energy. Potential energy can be gravitational, elastic, or involve both. Let's try an example using the conservation energy. Starting from rest, a child zooms down a frictionless slide from an initial height of 3.0 meters. What is her speed at the bottom of the slide? The child's mass is 25.0 kilograms. As always, we should write down the known information. The initial velocity is 0 meters per second as the child is starting from rest. The starting height is 3.0 meters, and we want to find out the final velocity or final speed at the bottom of the slide. Oh, and the mass is 25.0 kilograms. Since the child is going to end at the bottom of the slide, we can say the final height is 0 meters. Let's write our conservation of energy equation. Initial potential energy plus the initial kinetic energy equals to the final potential energy plus the final kinetic energy. There are no springs involved in this problem, so the potential energy is due to gravity. We can go ahead and write in the potential and kinetic energy equations then. Initial kinetic energy is 0 because the initial velocity is 0. Final potential energy is 0 because the final height is 0. This leaves us the initial potential energy equaling the final kinetic energy. We have all the known information, so let's put it in. This gives us 735 joules equals to 12.5 times the final velocity squared. Working this out, her speed at the bottom of the slide is going to be 7.66 meters per second. That concludes our example problem and this video. I hope you found it helpful, and thanks for watching.